Hey guys, welcome to my class Python for Beginners, and this is lecture number 16. And today we're going to continue talking about classes and objects. So this is the second chapter on the topic of classes and objects. So first up, let's open our Python file from the previous class, which I guess we named 15.py. Let's see. Should be a file 15. There it is. Alright, so this class had the definition of the point class. So let's just put all of the previous functions in quotes. Let's just actually remove all of this. So I just want to print everything, and I will just say alright. So let's define another class today. So let's just say that we want a class to represent a rectangle which is located somewhere in the xy plane. The question is, what information do we have to provide in order to specify such a rectangle? To keep things simple, assume that the rectangle is oriented either vertically or horizontally, never at an angle. A conventional choice is to specify the upper left corner of the rectangle and the size. So again, we'll define a new class and provide it with an initializer and a string converter method. So let's write our new class today. And let's say this is the class rectangle. And there is an init function in it. Oops. Init. So the default self parameter and the position, the width and the height. Alright. So this rectangle object is going to have some attributes, which are the first is the corner, and this corner is actually the position. Then self dot width, which is equal to w, and self dot height, which is equal to h. Alright. Next up is our string function. Oh man. And so what it does is it returns business, s, which is the self dot corner, self dot width, and self dot height. Okay. So now this is our class. So let's say you want a box and you call the initializer or the constructor function in this way, and you provide the position or the corner as a point object. So your class definition for point is already there in this file, this one. The corner is again a point object. So let's just place it at 0, 0. The width I say is 100 and the height is 200. Alright. Let's just say another object. Let's call it a bomb. So there is another rectangle, and this could be point 100, 80. And a little small rectangle we have here. So now you say I want to print box. So box is box, print bomb is fine. Alright. So let's hit F5 there. So boxes x is 0 and y is 0, 100, 200. So you'll note here that the %s we used to print the self.corner. Now since this is a point object, so the string method of the point class has been called. And because it is a point object, so the string method applicable on that particular object has been called to print the x and y corners of this object. So to specify the upper left corner, we have embedded a point object within our new rectangle object. The variable box points to an object with 3 attributes. 2 are integers specifying the width and the height, and third is a reference to another object, point object. So now let's talk about the dot operator. So the dot operator composes, for example, we can write something like a box dot corner dot x. Let's try to print this, and it prints 0, and com dot corner dot x is 100. So it's 0 and 100. Alright. So this box dot corner dot x means go to the object that box refers to and select its attribute name corner. Then go to that object and select its attribute name x. So the next thing we're going to talk today are that objects are mutable. So we can change the state of an object by making an assignment to one of its attributes. We've already seen that. For example, to grow the size of a rectangle without changing its position, we could write something like box dot width plus plus equals 100, something like this, and similarly for the height. So of course we'd probably like to provide a method to encapsulate this inside the class, as we've been doing all along. So we'll also provide another method to move the position of the rectangle elsewhere. So now you can have a method which is a grow method. So grow method takes self, the delta width and the delta height. All it does is it increments the current width attribute by this thing, and the self dot height by the delta height. Oh, that's it. Okay. So and now let's write a move function. So move function isn't all that complicated. It's a move function, takes the self and let's say you want to move the x corner by dx and y corner by dy. So all you say is the self dot corner dot x plus equals to dx, self dot corner dot y plus equals to dy, and that's all. Okay, let's talk about the concept of sameness in objects. So when we talk about objects, there is an ambiguity. For example, if 2 points are the same, does that mean they contain the same data, which mean the coordinates, or that they are actually the same object? So we have already seen the is operator in the chapter on lists, where we talked about aliases. It allows us to find out if 2 references refer to the same object. So if we said something like, okay, let's write p1 is equal to point 3, 4, and p2 is equal to point again 3, 4, and now we say print is p1, print p1 is p2, and we get a false. So even though P1 and P2 contain the same coordinates, they are not the same object. If we then assign P1 to P3, then the two variables are aliases of the same object. So when you say that P3 equals to P1, you actually mean P3 points to the same object as P1. Now if you say P3 is P1, you get a true. So this type of equality is called a shallow equality because it compares only the references and not the contents of the object. So to compare the contents of the objects, a deep equality is required. We can just write a function called same coordinates, and same coordinates you can just write a function same coordinates, and it takes 2 points P1 P2 and it return P1 dot x equal to P2 dot x and and P1 dot y equals to P2 dot y. So if both of these statements are true, only then the same coordinates returns are true. So now if we create two different objects that contain the same data, we can use the same point to find out if they represent the point with the same coordinates. So now if you say print same coordinates P1 and P2, and now it's true because we have written the function on our own and we know that it compares the coordinates. So of course the two variables refer to the same pardon me. So of course if the two variables refer to the same object, they both have shallow and deep equality. Okay, let's talk about copying now. So aliases can make a program difficult to read because changes made in one place might have unexpected effects in another place. It is hard to keep track of all the variables that might refer to a given object. So copying an object is often an alternative to aliasing. So the copy module, and we'll talk about modules in lecture number 18 I guess, but bear with me. Think of a module as something that you can a function that is provided in some library and you are allowed to use that function, and it's implemented behind the scenes. So the copy module contains a function called copy that can duplicate any object. Okay, for example, let's just put everything in quotes now. Okay, so import statements are usually the topmost statements in any Python program. So I am importing the copy module and I say that P1 is point 3.4 and now I say P2 is, okay, this is P1. Now I say P2 is copy. So this is the module name. Copy is the module which we have imported, and I am using the copy function format, and I want to copy P1. So now if I say print P1 is P2, and it is false. But if I say print same coordinates P1 P2, this is true. So once we import the copy module, we can use the copy function to make a new point. P1 P2 are not the same point, but they contain the same data. So to copy a simple object like point which doesn't contain any embedded objects, the copy function is sufficient. This is called shallow copy, because something like a rectangle which contains a reference to a point, copy doesn't do quite the right thing. It copies the reference to the point object So both the old rectangle and the new one refer to a single point. So, for example, if we create a box B1 in the usual way and then make a copy B2 using copy, invoking a grow on one of the rectangle objects would not affect the other, but invoking move on either would affect both, because the corner position is a single point and both the B1 and B2 have the references to the same point. This behavior is confusing and error prone. The shallow copy has created the alias to the point that represents the corner. Fortunately, the copy module contains a function named deep copy that copies not only the object but also any embedded objects. It won't be surprising to learn that this operation is called deep copy. So let's say we had let's have a B1 is equal to a rectangle. Rather, let's copy it from here. Oops, come. Do you have any rectangles here? Okay. We have, so let's say we name our, let me copy this, guys. Okay, so let's say B1 is this thing, and now I say then B2 is equal to copy dot deep copy B1, and now if I say, and now B1 and B2 are actually separate, completely separate objects. So B1 dot X, B1 dot corner is B2 dot corner. So this is false. But if we had used just the copy command, then the corner was the same. So if you actually move one, both the rectangles would have moved. So I hope you understand what's the importance of the copy and what's the importance of a shallow copy and what's the importance of a deep copy. So guys, with this I want to end, and next class we're going to talk about operator overloading and the concept of inheritance. See you around, guys. Take care.